My name's Andrew Mays, and I'm just going to present you my code instead of putting it into the PowerPoint slides like this. I think it'll be a bit better because I tried to put it into the PowerPoint slides, to be honest, and there's just a bit too much, and I wasn't sure which parts you wanted to look at in that, so I just wanted to quickly go over it instead, and I'll upload this to YouTube, so then you can just click on the link. So you just got your installations. I'm not going to run that, and you've got Poplar, which you need to run, and you need to download this Docker image, which is a Postgres Docker image with a PyG vector extension enabled. Once you have all that, you'll just import your libraries. Hopefully that all works well on the first go. Also, there's the I've got for Linux and Mac. I don't have for Microsoft, so you'll have to figure out how to do that one. So just going into the code, so I pretty much just created a class for the document database. Obviously we're just setting up a temporary Postgres database with the PyG vector enabled. So you're just creating a database name. So just going PyG vector example, and then you've just got your Docker image. It's going to connect it up, sync it all up. Here, when we initialize a database, what we're doing is we're going to create the vector extension, the PyG vector extension. If it isn't already created, we're going to register it, the connection. If it finds the data table documents, it's just going to delete it, and then we're going to recreate it. So we just don't have any errors. Then here, we're pretty much creating the function, which is called maxim. So this is called maxim, and this function is pretty much the similarity function, which is used to then determine the rankings or the retrievals for the RAG. This is specific to like Colbert or like Colpally, or I'm using Colgwen. And this is cool actually, because this means then you're calculating your similarity score. So this is like when you use a dot product, or when you use a cosine similarity, it's using a different type of similarity, which is called maxim. It uses a dot product with inside it instead of doing it based upon one single vector to one single vector. It's doing it over a multi-dimensional vector, and so you're actually doing it over the token. You're doing it at a token level, the similarity, instead of doing it at, say, like the final output of the embeddings. So I'm not going to go over like literally every line that's in there. So they've just got pretty much like you've got your add your document embeddings, which are your image embeddings. So this is where you pass your image embeddings, and they'll put that into the database. The only thing that's going into the database right now is the images or the documents. Then here you have your query, so you're going to pass it a query, your query embeddings or your text embeddings, and then based upon those text embeddings, it's going to then call your maxim or your similarity function. And then you've just got your shutdown, so just cleaning up your connection in the database. So as you can see here, I've already ran it, and here it's just literally setting up the database and all that. So you can see it's running with PyG vector. It's just set up like a generic username and all that kind of stuff. I haven't implemented any sort of like authentication or security type stuff, but I don't think that's the main point of the exercise. So moving on towards the embedding model, as I said before, I'm using Colgwen, and so I've just created a class which is sort of just going to do a couple of the things that we really want it to do, especially not only calculating the embeddings for each image and stuff like that, but also for like quantizing our vectors and stuff like that, which will then allow us to put that into the PyG vector or our Postgres database. So Yeah, so you just got here, you generate embeddings. This is just like where you'll be able to pass either the image or the text embeddings. So if you look just down here, you'll see that I'm calling this function, and you have this function within the generate image embeddings, but you also have it within the query embeddings. So it just generalizes that bit of code, and it's like standardized. You can pretty much see between the image embeddings and the query embeddings, they're pretty much identical, except you've got processing queries, you've got processing images here. So then when that goes into the model, it's able to handle those two different processes, which you can see just here, differently because they have keywords, different keywords associated with each tensor or vector. And then you just got the quantization going on, and that's just to store your vectors in an efficient way. I did have an unexpected output with that, where it did slightly decrease the performance of the retrieval by 7%, but and I didn't expect that. It wasn't expected when I was going in and doing it, but that's something maybe I should have to look at, and it may be a future improvement. So we're just quantizing, so it's just going to put it into zeros and ones and stuff like that. We're just going to go into a binary quantization. And so it actually makes it pretty quick, like the retrieval and that. We'll see that in the presentation with the results. So here we're just processing our files. So these are the files that you gave me. Just over here we can see. So you can see you got your text files, okay. And we also have the PDFs, because it seemed like you wanted a multimodal approach where you had text, you had images, graphs, and stuff like that. So I thought, well, and I know when you only do like text-based RAG setups or projects, you can run into the problem of, or you run into the question of chunking. And so when it comes to images or documents, chunking is actually a little bit more simplified, I think, where you're literally chunking based upon each page. So pretty much what I did was I converted the text files into PDF files. It's not actually rendering. And then those PDF files can then be used, each page then can be represented as an image. And so this is just going through that, so you can see like get non-PDF files, and so then that's going to be used down over here, I think. Where is it? It's used down here. Sorry, it's used down below here. And then they'll be eventually passed into this function, which will be then converting those text files into where they're obviously going to read them down here. They're going to read them, and they're actually then going to convert them into a markdown file where it's broken down or it's chunked into a per page basis. And I did have to implement one little detail, which is a bit out of the norm. Detect the encoding. I think when you saved your text files, we're using Microsoft product, and the thing is I was running it on a Mac and Linux, and it wasn't able to open up the files properly, so I had to detect the encoding and then transfer it to the encoding that I wanted, or the standardized encoding, which is the UTF-8. And so then I just did that, so then you could have your images. And so then when you have your PDF, you go PDF to images. This is just the last thing. After you've saved all your PDF files and stuff like that, it's just gonna give me that PDF as a list or a sequence of like PIL images or PIL images. And so then we just got here a couple little helper functions. This is cleaning the cache, because we're going to be using the embedding model, and later on the same type of model but in a different format, into a large language model format, into a decoder style transformer format. Because I'll be using structured outputs for like the guardrail, saying is this question relevant or is it irrelevant, because you were quite concerned about if you wanted the model to respond or not. So I added an additional guardrail to ensure that there wasn't any sort of unintended or unexpected responses. And then you've just got a couple of little things which are the scores that I'll be using to calculate later on on how well it responded, or based upon the outputs, comparing pretty much the outputs of the LLM I'm using compared to GTP Cat 4.0, sorry. And so I'll be using that pretty much to say, is this similar enough to the outputs of a high performing model? In this case, it will be a GTP 4.0, compared to my smaller 7 billion parameter model. So here I've just got my prompts. This is for the RAG. So this is just literally to say, is this, given a page, is this question relevant to this page